Now, question number 5. So in the question number 5,
Wait, so is that the final answer?
that's not the final answer. I told you that it is easy from here you to go.
Oh, so you just do the partial?
There's no need to do partial. You have to use one formula from Laplace table.
Oh, okay.
Okay, that is inverse Laplace, and you will have your solution. So now question number 5. I move my pages and then the question sheet goes down somewhere. So here. This was question number 5. Oh no, this is question number 5. Use the Laplace transform to solve the initial value problem. So it looks big, it looks difficult, but it is not like that. So dx by dt is equals to y minus 1. dy by dt is equals to minus 3x plus 2y plus e raised to power t, I think so. And initial values we have x0 equals 0 and y0 equals 0. So apply Laplace first. Okay, now applying Laplace on the first equation, we have x of s minus x of 0 equals y of s minus 1 over s. Fine. And for the second equation, we will apply, it is going to be s, y of s minus y of 0 equals minus 3x plus 2y plus et. So what will be the Laplace here?
One over x minus 1.
1 over s minus 1. So 1 over s minus 1. So this is 0, this is 0, no botheration, fine. So sx minus y equals minus 1 over s, sy minus 3x minus 2y equals 1 over s minus 1. So our terms will become sx minus y equals 1 over s and s minus 2y. So let's write by the other side so that our x is separated. So minus 3x, is it minus 3x? Yes, it is minus, no, it will be plus because on the other side was minus 3. So it is plus 3x plus s minus 2y equals, this is minus 1 over s, we have 1 over s minus 1. So look, it is a negative 1 over s, you are right. So till here, so this is, we have simplified it into a form we can solve. Yes, I can go up where? This is the, we started question. Okay. So this minus 3 will become plus 3 on this side, and this is plus 2 will become minus 2. And here we have, so here again, we will use the method we have already used. Multiply it with, first term, multiply it with 3, and the second term, multiply it with s. We will have 3sx minus 3y equals minus 3 over s. Here we will have 3sx plus s into s minus 2y equals s over s minus 1. So when we have these two, we can cancel our one variable. This will be gone. We have minus s square minus minus plus 2s minus 3y equals, this is minus 3 over s minus s over s minus 1. So now you have the form where you can solve it. So we have minus 1 plus 2. So y will be equals to minus 3 over s minus s over s minus 1 multiplied by 1 over whole term minus s squared plus 2s minus 3. Now you can solve it, okay? From here you can solve it. So you will get y, then you will apply it into the x. So here in this question, we are seeing the combination of two questions, Laplace transform and the, what was the first question about? Again, my sheet is gone. I put it carefully every time, but it's almost go down. So first question was systemic elimination. So it has to, yeah, systemic elimination. Thank you very much. So systemic elimination and Laplace together. I hope you can do it from here.
Would you say it's easier in general to solve for y and then plug y into the equation, or is it easier to do systemic elimination for x and y?
So no, you will solve it for y, put it in x, and then it will be easy. I think so. Okay.
Because I know sometimes there's like very long like answers for y, and then taking like the derivative 2 times is like pretty
So
long.
then don't go for plugging in. Try the x to remove y and solve it for x.
All right, thank you.
Because if you, this is for your convenience. If you think it is easy, do it. If it is not, then you can use the other way. Solve y again, solve it again with removing y, and you will find this answer for x.
Are both ways always correct?
Yeah.
Like, is there any limitations?
No, there's no limitation. Both ways are correct.
Okay, thank you.
The answer should be correct. Fine. So can I do it one time? Yes, the thing is I am not allowed to give you the final answer. I am trying as much as I can. So hopefully this will work. I don't think you can't do it. So let's go for the question number 6. It is show that functions are orthogonal or not. So this is also, you have only 6 sections to cover. So you can do it. I mean, this is, so our first function is e raised to power x. Our second function is x e raised to power minus x by 2. So when you write the question, try to be very careful, because whatever you write, you solve it. And if you make a mistake, then it carries on the whole question and you lose marks. So try to be very careful. And we have the interval here, which is from 0 to or 0, 1. This is our interval. If we go for the orthogonal method, if you remember, we have method f1, f2. This is the formula. We take the integral between the limits, between our interval. f1x multiplied by f2x dx. This is the formula. If it is equals to 0, they are orthogonal. If it is not equals to 0, they are not. So, do you want me to solve it? I mean, okay,
No, that's fine.
0, 1, e raised to power x multiplied by x e raised to power minus x by 2 d of x. So it will become, this will multiply with this and we will left with x minus x by 2 e raised to power minus e raised to power x dx. So here you can solve and you can find out it is 0 or not. Yes. Okay, Sharma. So let's solve it. X squared by 2, 0 to 1 minus 1 over 2 x e raised to power x 0 to 1 dx. So here you will use integration by parts and in 1 or 2 steps you will be done. So I hope you can do it now. I will stop here. In the question number, yes, any question? This was
Sorry,
easy.
is this being covered on the exam? Because is it, do you know what section this is?
4.1, you
This is
idiot.
orthogonal. I think it's
Yeah.
12.1 or
Yeah, it's 12.1.
yeah.
All right, thank you.
So you have 6 sections to cover, 3.12, 4.4, 4.6, and 12.123. Right? Okay, question number 7. It is long. So, but the way it is has, you have to be so when we find the question is about the Fourier series expansion. So you should know 3 formulas. I don't know they will give you or not, but they did not mention it on the D12. Okay, they said we will give you the table of Laplace. So for this, you should know the formulas for 3 terms, A naught, AN, and BN. Okay, for A naught, we have the formula. Where did I put all those formulas? Okay, my formulas are, oh, fine. So it is 1 over P minus P to P, f of x dx, simple integration of the function in the limits. AN is same formula, but multiply the function with cos of n pi divided by px dx. Okay, and for the bn, same formula, you have to multiply it with sine of n pi x. So they are not hard to memorize, but keep it in mind. If they don't give, you should be ready for that. Now, when you have this kind of an interval, you can divide it in 2 parts. So you can make it 0 here, and you can multiply it with 2 because you are dividing the interval into 2 equal parts.
For B sub n, is it 1 over P or is that A over P?
Sorry?
For B sub n, the coefficient in front, is that?
Yes, they are coefficients, but you should remember these 3 formulas.
Yeah, but the coefficient in front of the integral, is that?
Yeah, I'm going to write the Fourier series formula. So they are used here.
Sorry,
Okay?
but is that 9 over P?
Oh, they are 2 over P, not 9. Just 1 minute. I said when you have interval like this, you can, okay, let me write it again. You will confused here. So let me, this is 1 and this is minus p. Fine. So there is a rule when you have minus p to p and something here dx and whatever this is here. So you can divide this integral into two equal integrals and you can write it as 0 to p. Fine. So you can apply this method on these coefficients.
Isn't that only the case when it's an even function?
Only in the even function.
Yeah.
Okay, check it. I didn't check it. You check it.
Yeah, I agree with Gita one. Because I
Okay.
think if it's like half range or a cosine series, then you can, or like an even function, yeah, then you can do that.
And in the sine series, we can't do that.
You can do that for a
You can do
odd
it as
function.
long
You
as-
can do that for only b of n if it's a odd function.
If it's an odd function, it's just 0.
An, yeah, an is just 0.
A n
But
becomes 0,
but
yes.
but
And for the even
for yeah,
function, bn is 0.
yeah. But I think this function is e to the x, so it's neither.
They are neither.
I think so. If it's e to the
Okay.
power of x.
So when we write the Fourier series, we have both parts in it. Fine. So our Fourier series is in fact a naught over 2 plus summation n is equals to 1 to infinity a n cos of n pi over px plus bn sine of n pi over px. This is our Fourier series, okay? Fine. This is the total series. But when you have a function, sine function, odd function, you will skip this cos part. And when you have even function, you skip the sine part. So let's move on. So these were the formulas we were going to use. So let's start the question. We have the question, we have f of x is equals to e raised to power x, and our interval is from minus pi to pi. So first we will find these three terms. So a naught will be equals to 2 over pi 0 to pi ex dx. The simplest part is a naught. So it is going to be 2 over pi ex 0 to pi, which is equals to 2 over pi e pi minus 1. Fine. For the an part, we will go here with 1 over pi, okay, 0 to pi, we can use this one at least. Fine. Ex cos of n pi over pi x dx. Pi will be cancelled. So we have 2 over pi 0 to pi. The thing is 0 makes your life easier here. When you apply the terms, some will become quickly easy 0.
All right, how did you get 2 over pi if e to the x is not an even function? Because I'm pretty sure you multiply the integral by 2 and do it from 0 to pi only if it's an even function. And I don't think e to the x is an even function.
I think
You
you're
don't
wrong on
think?
that rule. I think you can do it in either way.
You can't do it.
I believe it's only like if it's an even
No.
function, multiply by 2 and you do 0 to pi, and then if it's an odd function, it's just 0.
Yeah. I agree. Because from what I know, this, or at least from the lectures, the prof said the trick of where you just where you make the integral from 0 to p and you multiply the integral by 2, that only works depending on if the function is even or odd. But in this case, it's neither. So yeah. But yeah.
Okay, just 1 minute. I'm checking it. Try.
நெக்ஸ்ட்டுக்கு போ
I think
கடுப்பேத்தாத ஒண்ணு பாட்டு ஃபுல்லா கேளு இல்ல சும்மா அது பாத்து அதான் கேட்டுட்டே இருக்காத
excuse
அங்க
me.
வரைக்கும் கேக்குது கடுப்பா
Oh
வருது.
my God, oh my God. So let me open it. Yes, so I think you guys are right. So let's do it with minus pi and pi. Okay. It will not hurt us. So let's start from here and do it from the here. Okay. So this is 1 over pi and minus pi to pi. Now it's fine. 1 over pi e raised to power x minus pi to pi. So we have 1 over pi e raised to power pi minus e raised to power minus pi. For the an, it's if it's odd, so it will become 0. You think so? So let's see.
Yeah, it should be. Like if you graph like the cosine and then you just do like integrations of two sides, like
Yeah.
it'll be the same on both sides. And if you do the integration of like sine on both sides, if you add them, they should be 0. You know?
Cos of nx dx. Fine.
Exponential functions aren't either or odd.
Okay.
I watched the video how Majid does this. You have to do it. It doesn't
Okay.
equal 0. An doesn't equal 0 on this one.
I don't do that. It doesn't equals to 0. I think it doesn't equals to 0, but let's find it out. I don't know why it is deleted. Hopefully it will stay now. So let's move from here. It is minus pi and just 1. So here we have this one. We will use integration by parts. Okay. If you look at the both of them, you cannot get rid of any of them. Fine. So minus, we will have integration by parts. So it will become, I will take ex, u is cos of nx. So cos of nx multiplied by ex dx is ex minus ex dot minus sine of nx over n. So let me write it on the new line. So this is minus ex dot minus sine of nx over n dx. So this minus will become plus. And here we have minus pi to pi. And here we have minus pi to pi. So we have 1 over pi. And now we have cos of n pi multiplied by e pi minus cos of n minus pi is again n pi, fine. E raised to power minus pi. Here we will have plus. There are two terms. Again, we will take ex as v. So we have 1 over n sine of nx dot ex minus pi to pi. Sine of nx is cos of nx over n dot ex dx. So we have the same terms again. So if we go back, we have this term, okay? So let's call it I, this whole term. So if this is I, again, we have I here with 1 over n. So we have 1 over pi. This is 1. And we have cos of n pi is minus 1 raised to power n, e pi minus e minus pi, plus cos of sine of n pi is 0. Sine of n minus pi is 0. So it is gone. 1 over n square. This will become minus, and we have I. Okay, this integral will add to the first integral. So we will have 1 over pi plus 1 over n square, and I is there, equals 1 over pi minus 1 raised to power n, e raised to power pi minus e raised to power minus pi. So this is our first side is done. Which I don't think. Is it 0? It is not 0. Will it be 0?
I don't think it's possible for it to be 0 for exponential function. I'm not sure though, but I don't think so.
It's not. It's going to be very similar to an. I think it's in the homework. It's basically an multiplied by minus n.
Yeah. So an we have again here. So this is an plus 1 over n square. Fine. So we have found the first part. Now your integral is equals to this one. Go back, look here. This is your integral. Fine, we have solved this one. An was this one. So you can go on with that, or I have to solve the other part as well. Do you want me to solve the other part? It's fine or not fine. Any question, any comment? So our an is 1 over pi n. So let me erase it. This is the one. Our an was 1 over pi I plus 1 over n square I. So this is our term. So you can solve it from here. Should I solve the other part? Okay, no, so let's look at the exam. Do you want to see the exam midterm too?
Yes, please.
Okay. So this is my midterm. In the midterm, question number 4. So let's do the question number 4 in the midterm. It is use the Laplace transform to solve the integral equation. Do you want to solve another question? Because first question is just systemic elimination. We have done one part. So I hope you can do that. And 2, 3 are also Laplace. Third question is just like we have done here. Question number 4. Question number 3. See, question number 3 are very similar. And, well, not that similar, but you can solve it. So let's do the question number 4, which I think you would like to do. Right, what's wrong? Okay, just 1 minute, I touched it. Here. Oh no. So let's start new one. So this time we are going to solve midterm 2. So in the midterm 2, we have the question number 4 that use the Laplace transform to solve the integral equation. Integral equation is 0 to t e raised to power 2 tau minus 2 tau f of t minus tau d tau, and our right side is equals to t square minus f of t. So how we will solve this question? So let's write it. So first, our left side is going to be e 2 tau f of t minus tau d tau minus 0 to t e raised to power minus 2 tau f of t minus tau d tau, which is equals to t square minus ft. I just rewrite the equation. Okay. So now this is our first integral. This is our second integral. And this is third and this is fourth. We will deal with them. So 1, 2, 3, and 4. So for the fourth one, if we look, this is Laplace of f of t, which is equals to f of s. Fine. Fourth is solved. For 3, we have t square. Laplace of t square will be equals to 2 over s cube. It is solved. For the second part, we have Laplace of 0 to t. First part, let's do first part, second will be same. E raised to power 2 tau f of t minus tau d tau. So this is our Laplace. Okay, if I want to remove something, okay, let me write it in a smart way. Laplace of 0 to t e raised to power 2 tau f of t minus tau d tau. Fine. It is equals to Laplace of e raised to power 2t and Laplace of f of t. Okay. So this will be equals to 1 over s minus 2 for this one and f of s for the second one. So this is our first part. Okay, so now second part. For the second part, we will have again same thing. So Laplace of 0 to t e raised to power minus 2 tau f of t minus tau d tau. It will be equals to Laplace of e raised to power minus 2 tau Laplace of f of t, which will be equals to 1 over s plus 2 dot fs. So now we have solved the four parts and we have solved the equation by taking Laplace. So we can write it as 1 over s minus 2 f of s minus 1 over s plus 2 f of s equals 2 over s cube minus fs. Okay. So we will solve it. Let's collect the terms of function f of s. So we have 1 over s minus 2 minus 1 over s plus 2 plus 1 f of s equals 2 over s cube. So solving it, we get s plus 2 minus s plus 2 plus s minus 2 s plus 2 divided by s minus 2 s plus 2 f of s. I'm just solving this part. So this will be cancelled. We have s square minus 4 plus 4 over s square minus 4 f of s equals 2 over s cube. This will be cancelled again. So we have s square over s square minus 4 f of s equals 2 over s cube. So f of s is equals to 2 over s cube multiplied by s square minus 4 divided by s square. And now it will be equals to 2 s square over s5 minus 8 over s5. Fine. So you can solve it now, or I should go on. Okay. Someone said, let me finish this one. So f of t is equals to Laplace inverse. 2 is common to take out. So we have 1 over s cube minus 4 over s5. So this will be equals to 2. 1 over s cube is t squared by 2. And 4 over s5 is going to be t4 over 4 factorial into 4. So you have, sorry, t square minus 8 and 4 factorial. So it is t square minus 1 over 3 t4. This is solution. Any question? Do you want me to go up?
Quick question.
Yeah.
How did you get 4 over S5?
Oh, I take 2 common outside. Look, this is 8. Okay.
Yeah.
So
Mhm.
if I divide it by 2, it is 4. So 2 is outside.
Oh, okay. I thought it was S to the. Okay, yeah. Okay, got it. Thank you.
Anyone else? Any question?
I'm a little confused by your T4 over 4 factorial.
Oh, yeah. Did I make mistake here? It is S5. Fine, 1 over S5. So when we have 1, we have 1 over S. Okay. When we have S, we have 1 over, oh, sorry, T, we have S squared and so on. So it is, when you have Tn, you have a formula in the book. So use that.
Okay, and actually I see it now. Thanks.
Okay. So I saw this, so that's why I was not stopping anywhere. So do you want me to go up? You want to see anything else? So rest of the questions in your paper are just like as we discussed the other questions. Four. So basically mid 2 and the test 2 are similar. They have the same type of questions. Can you do 6, please? 6. Let me see if I have seen it or not. So it is half range cosine expansion of 2 minus 1. So I didn't see it. So let me have a look how to do that. Okay. If I can help, I will help. Okay. Cross. So we did questions in week 7. So I did not spend any time on this question. I will try and find some solution for it and I will send you guys. I will include it into my notes. I think it will take time. So let's finish it now. I mean, do you want to? Because I thought I did not see this question, in fact. So I will do that question and I will send you the solution with the notes. So let's finish this session and I will upload the recording as well as the notes and I will send them to the Kendall, whatever the name was. So he will share it on the site like he did last time. So did you get last time, did you get my notes and my recording?
We did, yeah.
Oh, okay, fine. So good to see you. Bye.
Okay, thank you. Take care.
You too. Bye.
See ya.
See ya.
I just have a question,
Yes.
like quick. So
Yes.
when you
yes.
did the Laplace inverse of 4 over s minus 5,
4 over
shouldn't it
S,
be 2? Shouldn't it be 2 times t to the power of 4?
4 over
No.
S minus 5. This one.
Yeah.
So what can it be?
I got 2t to the power of 4. I don't know how you got the 1 over 3.
Okay. So 4 4 is
Because where'd you
divided.
get the?
No, that look. Okay, let me write it again. This is 4
Because I
factorial.
don't get where you got
Fine.
the 4
No,
factorial from.
this is 4 into 3 into 2 into 1. Fine.
No, I get it, but where
This
did
4
you
will
get it
cancel
from?
this 4. Fine. And this
Yeah.
2 will cancel this 2. So we will left with 1 3. 1 over 3.
Yeah, but where did you get it from? Because isn't the Laplace of 4 over s to the 5, you just bring out the 4, or you could just keep it in and you do 4 over s to the power
It's
of 4
4
plus 1.
factorial over, it's 4 factorial over 5s. That's what my question was before. She did the inverse of it and just put it in it.
I just
The
took
inverse
Oh,
would
so
be,
this is right?
inverse
yeah,
of
she
it.
would, you have to do the inverse and take it out. She just put it in the next step there.
Oh,
Do you see that?
yeah, because I didn't take out a 2. I just kept the 8 in and just factored it out, but I guess I just did it wrong then. Okay, thank you.
Okay, welcome. Could go up just a bit. Okay. Where?
Well, I wanted to say thank you tonight too.
Sorry?
I just want to say thank you for tonight.
Welcome. I hope it will be beneficial for you. That's more important.
Thank you.
Welcome. So do you want to? You too. Bye. I will try today or tomorrow, inshallah. You too. Okay, everyone, good night and bye.